Okay, for packet 6, it's a lot of distributive method and just simplifying, and so that's one of the things I'm going to show you here. It's just a really extended, long version of distributive method and simplifying like terms. So first thing you should see, please excuse my dear Aunt Sally. That's one thing that I really want you to be thinking of. We got to do our parentheses first, so I am going to distribute anywhere there's parentheses. And again, over here I need to add a 1 and distribute a -1, which is always a confusing part. So 4 times x squared is 4x squared. 4 times 3 is 12. Let's go to my next one. 2 times x is a positive 2x, and 2 times 4 is a positive 8, so I add 8. And then -1 times x is a -1x, -1 times 3 is a -3. Now I can combine my like terms. 4x squared does not have a like term. There's no other squared term, so I just bring that down. Now I'm going to combine all my x terms. So this is going to be a positive 2x and a -1x. So 2x plus -1x is going to be a positive 1x. I'm done with those. Now I'm going to combine all of my constants. 12 plus 8 is 20, minus 3 is a positive 17. And so I end up with this trinomial. Things to always remember when you're doing problems like this is to take it one step at a time. It really breaks it up, and it actually ends up not being that complicated. Please excuse my dear Aunt Sally. Always we do parentheses and exponents first, then we move to multiplication and division, and then our last step is to add or subtract like terms. When you add or subtract like terms, make sure you do not change your exponents. There is no law for adding and subtracting terms with exponents. The next type of problems that you're going to see in this packet are pattern problems, and we've done some work on this in class, but I wanted to make sure when you have patterns, make a table and plug in the values to your answer choices. Even if you don't make a table, you have to use your answer choices by plugging in values for n. So you have to know what n is. A lot of times you'll hear nth step. That means whatever step you're on, that's what n is. Not how many squares there are, not any of the other stuff. It's whatever step you're on, that is what n is. And so that's why I like making a table like this one over here. So I made a table, and now that I know what n is and what my answer is supposed to be, I just plug in into my answer choice and see if it gives me the output. So this is basically my input, this is my output, and I'm trying to see if they're the same. So n squared minus 3. First thing I'm going to do is plug in 1 for n. So 1 squared is 1, minus 3 does not give me 2. So I can go ahead and eliminate answer choice A. Now I go to answer choice B. Again, this time I'm still using 1 for n. So 2 times 1 is 2, plus 4 is 6. And this one says it's supposed to be 5. So again, I can count that one wrong. Now I go to C, and again I'm plugging 1 in for n. 3 times 1 is 3, minus 1 is 2. It worked. Now go to the next one. Let's plug 2 in for n. 3 times 2 is 6, minus 1 is 5. It worked. Let's go to the next one where n is 3. So 3 times 3 is 9, minus 1 is 8. And the last one where it's 4, 3 times 4 is 12, minus 1 is 11. And so that works all the way through. You have to make sure that it works all the way through. They'll try and trick you by having it work for maybe the first 2 or the first 1, but it has to work all the way through. So the number one thing when you're working with patterns is to make sure you try and make a table and then always know what n means. Whenever it says nth step, that means whatever step you're on, that's what n is.